welcome to the Law of Conservation of Matter and Atomic Counting. What we're going to be getting into next is balancing chemical equations. The reason that we balance chemical equations is because of something called the Law of Conservation of Matter. This is interchangeably sometimes called the Law of Conservation of Mass, and they mean basically the same thing. What this law says is matter cannot be created nor destroyed during a chemical reaction. All reactions have to show a conservation of mass, energy, and charge, which is why we balance them. So we're going to demonstrate this conservation of each of these things by balancing chemical reactions. We're mainly going to be focusing on balancing for mass right now, although we do look a little bit at charge later. These reactions are balanced for energy. We just don't really necessarily show that in the way that we write them. That's not something we really worry about, but you should understand that they are balanced for energy as well. In order to be able to balance chemical reactions, we have to be able to account for atoms. So we have to be able to look at a formula, like for example, calcium nitrate, and determine how many atoms of each element are here. It's pretty clear that there's one calcium indicated by the fact that there's just a little invisible one next to that. We have two groups of nitrate, so what we actually have to do is distribute this two. So we actually have two nitrogens. Each group of nitrate has 3 oxygens, so we're going to distribute that to those 3 oxygens, and it gives us a total of 6 oxygens. If we look at this depiction of that, we have our 1 calcium right here, 2 nitrogens, 1, 2, 3, 4, 5, 6 oxygens. So here's a couple of quick examples of counting atoms. So this 2 right here goes with sodium, therefore we have 2 sodiums. There's an invisible 1 with carbon, and we've got this 3 with oxygen. Calcium is pretty straightforward, it's just 1. This 2 goes to everything in this group, so it tells us we have 2 chlorines, and we have 8 oxygens. Here's a couple of examples to try. Pause the video and then check your answers. Let's go over each of these in a little bit more detail. Ammonium chloride is a pretty straightforward example. We have 1 nitrogen, 4 hydrogens, and 1 chlorine. Ammonium oxide is a little bit more confusing because you have this 2 here. So we have 2 of those guys. 2 times 4 is 8 of those guys, and 1 oxygen. The 3 goes to the calcium, so we have 3 calciums, 2 phosphoruses, and 8 oxygens. 2 more quick examples just to make sure you've absolutely got the hang of this. So in strontium phosphate, 3 is going to just the strontium. You're distributing your 2 to everything inside of those parentheses. This 2 is going to go to this nitrogen, that hydrogen, and then we just have an invisible 1 by the oxygen. So in our top example, we have 3 strontiums, 2 phosphoruses, and 8 oxygen atoms. In our next example, we have 2 nitrogen atoms, 8 hydrogen atoms, and 1 oxygen atom.